hertz, use the same speed of sound in air, and here's the original equation, and I've gone and written this up with all the variables. I just don't have the plus or minus in here, all right? We need to think about that. The source is going to the right at 20 meters per second. The observer, the person that's going to hear this, is traveling to the left, to my left at least, 30 meters per second. They're going towards each other, which means you know they're going to hear a higher pitch. Remember that the equation, again, this is the basic equation, the motion of the source is in the denominator. You've got V here, those are both 345. The motion of the source is in the denominator, the motion of the observer is in the numerator. Okay. Now, again, you need to think this through. You need to put on your thinking caps and think about it. There's a little trick to this, but once you get it and practice it a couple times, it's not that hard. To figure out whether or not to add the 30 in the numerator or subtract it, just pretend for a moment that the source, I'm talking about the numerator, the observer, pretend like the source isn't moving. Just looking at this, is the observer going towards, is that blue car going towards the green or away from it? Look at the arrow. It's going towards it. Forget that this is moving just for a second. That arrow is to the left. It's going towards it. Does the motion of the observer towards the source lead in and of itself to a higher pitch or a lower pitch? Does the motion of the observer at 30 meters per second going towards the sound source, that in and of itself, forgetting the source, what the source is doing, that in and of itself, does that motion lead to a higher pitch or a lower pitch? It leads to a higher pitch. Whenever you go towards, you hear a higher pitch. So I add the 30. Now, let's do the same dissection in the denominator. Do we add or subtract the speed of the source, the 20 meters per second? Just for a moment, forget that the observer is moving and just look at the source. Does the motion of the source at 20 meters per second towards the observer, that arrow means it's going towards it, does that type of motion in and of itself for a source lead to a higher pitch or a lower pitch? It leads to a higher pitch. All right? We know that's true. Okay? You're going to hear a higher pitch when a sound source comes towards you. So to make this pitch higher than that, I make the denominator smaller. Both of these motions lead to a higher pitch. And that's why this is added, and that's why that's subtracted. Now maybe this weirdness over here makes more sense, where I put plus and minus in the numerator and minus and plus in the denominator. Because if you want to make the pitch higher, you do the exact opposite in the denominator that you do in the numerator. All right? Both of these lead to a higher pitch. Okay. Now we'll put in the numbers. This is 440. Then that's 345 plus 30 all over 345 minus 20. 440, what's that? 375 all over 325. I've already calculated it over here. And I get 508 hertz. 508 hertz, which is certainly higher than, significantly higher than 440 hertz. Now the next question is what happens once they pass each other? So thank goodness they missed each other. And now they passed each other, keep going. The blue keeps going that way to my left, and the green keeps going that way to my right. What is the observer, the blue one, going to hear? So let me redraw it. Erase these. So there's the blue one, traveling at, what did I say, 30 meters per second. That's the observer. And here's the source. Traveling at 20 meters per second. And I'm sure you figured this out. Now both of these motions lead to a lower pitch. The observer is going away from the sound source. Again, pretend like the source isn't moving for a second. That motion right here, when you go away from a sound source, you hear a lower pitch. That means I need to subtract the speed of the observer, because it's going away from the sound source. Now do the exact same thing over here. This source is moving that direction in the opposite, going away from this observer. And when a source goes away from an observer, that in and of itself leads to a lower pitch. So both of these contribute to a lower pitch. How do I make this pitch lower in the denominator, or make the denominator bigger? Counterintuitive. So this is 440 times, what's that, 315 in the numerator, I think, and 365 in the denominator. And the answer is 380 hertz, substantially lower. 380 hertz. And we're done with that one.